Well, now let us go through the very important problem in this session, that is the planetary motion. So, in a planetary motion, what is important is to find the orbit for the gravitational interaction. Here we consider the potential U of r as minus g capital M into small m by r, that is equal to minus c by r, where c is g m small m. Capital M can be the mass of the sun and small m can be mass of planet, or capital M can be mass of a planet and small m can be mass of a satellite. Okay, we can consider all these things. So we earlier studied the equation for orbit, that is d theta by dr is equal to L by mu r square root of 2 by mu into E minus U effective. Here U effective is U of r into L square by 2 mu r square. U of r is minus C by r plus L square by 2 mu r square. We are going to solve this with the potential of the gravitational potential. D theta by dr is L by mu r square. We are substituting the value of U effective here, 2 by mu and E minus E plus C by r minus L square by 2 mu r square, that's equal to L by, I'm taking mu r inside the square root and leaving one r outside, that is L by r into square root of mu r taking inside will be mu square r square into 2 by mu E plus C by r minus L square by 2. The calculations are simple. I'm changing to this format to use some standard integral. So it will be look like this: d theta is equal to L by dr r into square root of 2 mu E r square plus 2 mu C r minus L square. Now I am taking the integral on both sides, so it will be integral d theta. Sorry, d theta is equal to integral L dr by r square root of 2 mu E r square plus 2 mu C r minus L square. So now I want to calculate the integral. For that I am using the standard integral. Integral dx by x square root of ax square plus bx plus c is equal to 1 over root minus c sine inverse bx plus 2c by x root of b square minus 4ac. So I am using here x is replaced by r, a is 2 mu e, b is 2 mu c and c is minus L square. So on the integral left hand side, integral d theta is theta plus a constant. I am taking the constant as minus theta 0. So theta 0 is some constant of integration. I am taking minus theta 0. No, that is of no such difficulty to take as minus theta 0. You can take plus theta 0 also, no problem. So this is, on substituting you are getting L by square root of L square, that is this L is this one, sine inverse 2 mu C r minus 2 L square r, and simplifying L by square root of L square is 1 sine inverse, and I am taking 2 from here and here, and 2 from the square root I am taking 4. So on simplifying, what I am getting is this one, sine inverse mu C r minus L square r in the square root of mu square C square by 2 mu E L square. Then therefore this is sine inverse, therefore sine theta minus theta 0 is equal to mu C, this first time, mu C by square root of mu square C square plus 2 mu E L square, then minus L square, this time L square divided by r root of mu square C square plus 2 mu E L square. Then doing this one, see, I am multiplying with square root of mu square c square plus 2 mu el square on both sides. I will get L this time L square by R square is mu c like this. Then I am calculating R from here. R is equal to L square by mu c. Then I am taking mu c from this term on the square root, so it will be 1 plus 2el square by mu c square over the root. So that is R is equal to L square by mu c by 1 minus square root of 1 plus 2el square by mu c square sin theta minus theta 0. And conventionally we are taking theta 0 as minus pi by 2. Okay, that is one convention. So theta 0 is some constant. So if I take theta 0 is minus pi by 2, so it will be sin theta plus pi by 2. Sin theta plus pi by 2 is cos theta. So therefore it will be, this equation become R is equal to L square by mu c by 1 minus square root of 1 plus 2el square by mu c square cos theta. So now this equation is in a general form of a conic section, say that we learned earlier. So comparing with this general equation, R is R0 by 1 minus epsilon cos theta. R0 is L square by mu c, and that is actually the radius of circular orbit. Epsilon is equal to 1 square root of 1 plus 2el square by mu c square, that is the eccentricity that determines the shape of orbit. Okay, so in Cartesian form, x is equal to r cos theta, y is equal to r sin theta, and the equation become this one, 1 minus epsilon square into x square minus 2r0 epsilon x plus y square equal to r0 square. This we learned while we discussing about ellipse. So there are different conditions. From this equation, epsilon can be greater than 1, equal to 0, equal to 1, and less than 1. These are three possibilities. Epsilon can be greater than 1, equal to 1, and less than 1. Let us consider what happens if epsilon is greater than 1. Okay, first condition. So epsilon is greater than 1 means 1 minus, so bigger quantity, so this term become minus. Okay, so what happened is, here the coefficient of x square is 1 minus epsilon square and coefficient of y square is 1. So therefore so this term is negative and this term is positive. Therefore the coefficient of x square and coefficient of y square are unequal and opposite in sign. Okay, therefore it is of the form y square, this will be minus, I will take some minus a x square minus bx equal to r0 is a constant, that is equal to constant, that is general equation. Okay, so the equation has the form y square, this form y square minus ax square minus bx is equal to constant. Okay, a is some constant, that will be going to be 1 minus epsilon square, and b is 2r0 epsilon. Okay, so actually this is the equation of a hyperbola. Okay, so epsilon is greater than 1, the orbit will be a hyperbola. So epsilon greater than 1 occurs whenever E is in this equation. Epsilon, this is greater than 1 when E is equal to, E is greater than 0. Okay, E is equal to 0, there is epsilon will be 1. That is next condition. So what happens if epsilon is equal to 1? In this equation, epsilon equal to 1, the coefficient x square becomes 0. So this is minus 2r0x plus y square is equal to some constant. So this is minus 2r0x plus y square equal to r0 square, that is a constant. Rearranging, you will get this equation, y square by 2r0 minus r0 by 2 is equal to x. This is actually the equation of a, you can say it is the equation of a parabola. Okay, it is the equation of parabola. So epsilon equal to 1, the orbit become a parabola. So epsilon equal to 1 happen when e equal to 0. Okay, now the third condition. Third condition is epsilon is less in between 0 and 1. Okay, so what happened in this equation? So it will never be equal to 1, less than 1. So this quantity become positive. So the coefficient of y square and x square will be positive but unequal. Okay, they are unequal but positive. That's the difference. So the coefficient of x square and y square are unequal but of the same sign. So therefore the equation is of the form, this is positive ax square, so this is minus bx plus y square equal to constant. Okay, that will be the equation, ax square plus bx plus y square equal to a constant, and this is the equation of an ellipse. Okay, remember one of the term minus bx, actually the term, this term, the second term minus bx, that is a linear term in x. That is happened because the geometric center of the ellipse and your center of coordinate, I repeat, the geometric center of ellipse and the center of your coordinate will not be same. That's the meaning. Okay, your center means the origin of your coordinate and the geometrical center of ellipse will not be same. That's the meaning. That's I am given. So here this one of the focus is taken as the origin of your coordinate. So geometric center will be somewhere here. Okay, somewhere here. So it will be some minus bx. This origin is some minus bx. That's the meaning. So normally one focus of the ellipse is at the origin. Okay, so what are the allowed values? So allowed values are 0 and 1. So our epsilon was this one. So epsilon is equal to 0 when this term is equal to minus 1. That is e is equal to minus mu c square by 2l square. Okay, and it is less than 1. So this this is minus mu c square by 2l square and is 1 when e is equal to 0. So that is condition, minus mu c square by 2l square less than or equal to e less than 0. So when e is equal to minus mu c square by 2l square, epsilon equal to 0. So epsilon equal to 0 means the coefficient x square will vanish. So this will be my, what is epsilon equal to epsilon equal to 0 means this equal to 1, that is x square plus y square equal to r0 square. That will be the equation. Okay, so x square plus y square is equal to r0 square. That actually the equation of a circle. That means in that time the orbit will be circular in shape.